So, second lesson in Chemistry 2.1. Here is the title, the learning objectives and the keywords. And what I'd like you to do is pause the video and have a go at these questions. So what is an atom? The smallest particle. They make up everything. What's inside an atom? So you've got your protons and your neutrons, and they're in the nucleus. And then you've got your electrons in the shell. How many electrons go in the first 4 shells? So 2 in the first one, 8, 8, 8. Draw the electron structure of oxygen. So oxygen's got an atomic number of 8. So 2 go in the first shell. 1, 2, 3, 4, 5, 6. So 2, 6. How do you work out group? How many are in the outer shell? How do you work out period? So outer shell will be group 6. How do you work out period? How many shells? So that would be 2. So atom. What is an atom? Atoms are tiny particles that make up everything, and you need to remember that definition and note it down. Element. So element, only one type of atom, or on its own or joined to another type of the same atom. So an element, you could have loads of nitrogens in a row, but it would only be nitrogens in that row. Okay, so they're all the same type of atom. Find these on the periodic table. Okay. So compound. A compound is different types of atoms joined by a chemical bond. So you could have sodium joined to chlorine, or we could have hydrogen joined to oxygen. Okay, they're compounds because they've got these chemical bonds. They're bonded together. And we've got mixtures. A mixture is different types of atoms or compounds that can be physically separated. Okay, so I could have H2O, so that's a compound, but then I could also have nitrogen, all in the same area, and then I could have some helium. And this is a mixture because these compounds aren't bonded to each other. This compound isn't bonded to these other 2 compounds. Okay, so review 1, press pause, and then I'd like you to tell me, are these elements, are they compounds, or are they mixtures? Okay, A, that is an element. B, that is a mixture of elements. Okay, this is also elements. This is a compound. This is a mixture. And then this is a compound. Okay. Moving on to the next bit then. So, no atoms are created or destroyed. This is a really important statement. Very important statement. There should be the same number of atoms of each type of element on each side. Okay, so magnesium, so you have 1 magnesium, you'll have 2 oxygens because oxygen is diatomic. That will make magnesium oxide. Okay, but you've got to put 2 there and a 2 there because then you've got equal numbers of magnesium and equal numbers of oxygen. So nothing is destroyed. You don't then, if you didn't have oxygen or something on this side, you don't then just end up with a helium on this side. Okay, nothing is created or destroyed. So you've started with 2 oxygens, you end up with 2 oxygens. So what I'd like you to do, again, pause the screen. Read this passage about chemical reactions and then have a go at 3 questions on the side. Okay, so define a chemical reaction. A chemical reaction is when two or more chemicals join together to form new chemicals. Give examples of everyday chemicals. Okay, so milk going off, cooking eggs. How do we know when a chemical reaction has taken place? Okay, a couple of things we might see, like a gas given off. What else might we see? Okay, so just to carry on going through that then, you might see a colour change. This will help you answer your final question. You might see gas given off, bubbles. You might see an energy change, so it might get hotter or colder. And sometimes we say that's exothermic, heat is exiting into the environment, or endothermic. New substances are formed. The change is usually difficult to reverse, okay? So you might end up with something that's different. Okay, so the next thing we're going to look at is forming chemical reactions. This can also be known as word equations. Whenever we're forming or thinking about word equations, we want to think about the reactants and the products. So the reactants are all our ingredients, the things that we start with, and then what we end up with is our finished product. Okay, and this is just a nice example. If we make a cake, we would start with the ingredients, mix, cook them to give us the finished cake. So if I was to write this as a word equation, obviously I've got my reactants, and then I've got my products. So we can always work out this. An arrow tends to connect them, and then all the things I react together are there, and then my finished product is there. Okay, nothing new has been added. It's just changed form. Okay, so often it changes name because it's changed form. So let's just have a go at this one together. So methane is burned in oxygen. It produces a gas known as carbon dioxide and water. Okay, so what are reactants? We've got methane and we've got oxygen. They're the two things we're reacting together. What are our products? Carbon dioxide and water. So if I was to put that in a word equation now, I'd do methane plus oxygen carbon dioxide plus water. Okay, so that's how we form a word equation. What I'm going to do is I'm going to help you, just give you another one as a little review. Doesn't come up often, but I just want everyone to have a go at it. So when I mix oxygen and magnesium, so oxygen and magnesium are mixed together. Okay, so reactants would be oxygen and magnesium. And that would make magnesium oxide. Lovely. Okay, so they're the kind of things that you might see. Often, see with oxygen, it always makes it oxide. So be careful that it doesn't make magnesium oxygen. It's just an example to help you with that. So another thing that you might be asked to do in terms of chemical reactions is to draw space filler diagrams, okay? So space filler diagrams are when you're giving a key, such as this. This key hasn't come out, which is a little bit annoying. Okay, so apologies for that. You'll be given a key. Sometimes it's different colours. Sometimes it is different symbols within the circle. All you've got to do then is draw out exactly what the compound will look like. Okay, they're often, so this one here is an element, it's 2 of it, so 2 nitrogens. This one here is a compound. They are joined together by a chemical bond. Okay, another thing to notice, if they asked you to draw something like CH4, so CH4, okay, contains 1 carbon, which you would then put in the middle. So you'd put your 1 carbon in the middle, and then you would surround it by your 4 hydrogens. Okay, so whatever element is on its own goes in the middle because they're all bonded to that carbon. Okay, you wouldn't see it drawn like this, and that's most probably the biggest common misconception you see. Put your lone element, which in this case is carbon, in the middle. You wouldn't see it drawn like that. Okay, also make sure they're touching because they are chemically bonded together. Okay, so make sure they're touching because they're chemically bonded together. So what I want you to do is to have a go at drawing these 3. Okay, so to have a go at drawing these 3 as space filler diagrams. Make sure you press pause so that you can have a go at doing it. Okay, so H2O, oxygen's the lone element, so oxygen's going to go in the middle, and then it's going to be surrounded by 2 hydrogens. Nice and easy. This isn't a hard topic at all, just something we want to get done. Okay, next one's 2 hydrogens. Hydrogen bonded to a hydrogen, and then you've got a nitrogen, which is your lone element. Luckily, nitrogen is just like that. And then the hydrogens, 1, 2, 3. Okay, obviously, you've must have drawn them better than me, but that's exactly what you've got to do. So that is looking at word equations and also looking at how we would draw them in terms of space filler diagrams. The next thing we're going to go on to is chemical equations. So to be able to write out a chemical equation, we first need to be able to write out chemical formula for different compounds that you may come across. Okay, so they're either going to ask you something like write the chemical formula of, or they'll say these are the charges, how would you write the chemical formula? Okay, so the one that we've been given here is magnesium chloride. So magnesium chloride. Okay, so they might say, what's the ionic formula of magnesium chloride, or the chemical formula? So sometimes they write ionic formula. Okay, this is a nice, easy topic. So what you do is you turn to your table of ions. Okay, table of ions is next to your periodic table. You'll get it in the exam, so don't worry. Turn to your table of ions and find their charges. Okay, so magnesium's 2+, chlorine is 1-. Okay, what I then want you to do, first things first, this is a 3-step process. Stop, top, swap, drop. Okay, so you need to remember that. So first thing you want to do is remove the charges from the top. Okay, so remove the charges so they are just numbers. So you've got 2 and you've got 1. Okay, then you're going to swap over the charges. Just swap them over, so 1 to 2, and then you're going to drop them down, and that's your chemical formula. Okay, what you'll often see is when it's a 1, they just remove the 1. Okay, just to make it look a bit neater. That's what you just need to practice. Okay, so top, swap, drop. Okay, I'm going to do another one. So over here, top, swap, drop. Okay, so in this table, they want you to basically fill in the entire table. Okay, it's worth 11 marks. That'd be a really nice question if that came up. Okay, so the next one I'm going to do is this one, magnesium 2+ and Br-. That's the next one I'm going to do. I'm going to fill in that box by there. So I'm going to use this space. So magnesium 2+, Br-. Well, that's technically 1-, isn't it? Because there's nothing else. So top. First thing I want to do is remove the charges. That's what I do when they're at the top. Okay, then I want to swap the charges. So top, remove the charges, swap. So Bmg1, Br2, I've swapped them, and then I'm going to drop them. So Mg1, Br2, remember you can get rid of the 1, so Mg, Br2. okay? And then all I do is write that in there. Now, the other thing I want to notice, okay, is just to be really careful of something like this by here, okay? So NO3 minus, okay? That little 3 has got nothing to do with that minus. Nothing to do with that minus because it's already on a subscript, okay? So that is just 1 minus. That little 3 has got nothing to do with it, okay? So we're just going to practice doing that one as well. So say I was going to do this box by here. So I've got aluminium 3 plus and I've got NO3 minus, okay? So I'm going to do them on the top. So remove the charges. NO3, 1, because it's only 1 minus. I'm going to swap over the charges. Okay, and then I'm going to drop the charges. Okay, now the only thing we need to do, because otherwise that's going to look really awkward, isn't it? By there. God knows what's going on there. So whenever it's 2 elements together, just put a bracket around it. Okay, whenever it's 2 elements together like that, put a bracket around it. And if I was to put that in my table now, I'd put LU bracket NO3 bracket. Okay, so pause the screen now. We've done a couple of examples together. Pause, have a go at the rest. Okay, welcome back. So this one then, just checking your answers. Okay, so that's what you should be getting, okay? This is going to come up for a couple of marks if they do a nice table like this, okay? So moving on to the last little bit about chemical equations, it is balancing equations. The last little bit, and this will all like kind of come together then, and I might give you a little challenge exercise at the end. So what we've got to do is draw a line down the middle, okay? So whatever you've got on this side, you need to have exactly the same number of on this side, okay? So how many products do I have? So I've got 1 nitrogen and I've got 3 hydrogens, okay? Reactants then, I've got 2 nitrogens and I've got 2 hydrogens, okay? So we need to get these numbers exactly the same. Okay, I can't just go and add an n there and be like, oh, they're balanced now. No, okay. I can only put numbers in front. Okay, so I can only put numbers in front by here. I can't just add my own versions elsewhere. Okay, and this is quite a hard concept to grasp. Okay, I can only put numbers in front. I can't just put numbers anywhere. Okay, so I'm going to start by trying to balance. So I've got 2 nitrogens on this side. I've got 1 nitrogen on this side. So if I put a 2 in front of there, and I'm going to change the colour now, put 2 in front of there. I've now got 2 nitrogens, but I've also got now, because I used to have 3 times by 2, I've now got 6 hydrogens, okay? So even though my nitrogens are now balanced, my hydrogens aren't. Okay, so I need to now add a number in front here so that my hydrogens will balance. So what number times by 2 is going to give me 6? So I'm going to put in there a 3. So 3 times by 2 would give me 6. Okay, and that's how we balance equations. Okay, you can only put numbers in front. And it is hard. We're going to do another one together and then I'm going to leave you a couple to practice. So same thing. I always put a line down the middle. Work out what I've got on my reactants, work out what I've got on my products, okay? So, I have got 2, I have got 2, I have got 1, I have got 2, okay? So, work out to balance the thing that isn't already balanced, put a 2 in front by here. So, I've now got 2 oxygens, but I've also got 4 hydrogens. So I need to do something to this one now because my oxygens are now balanced. I'm now going to put a 2 in front of there because 2 times by 2 will give me 4. And that's all balanced out. So last little bit now of chemical and word equations. Can you press pause and try and balance these? Okay, so first one, I've got 2 hydrogens, 2 chlorines. On this side, I've got 1 of each. Nice, easy one, put a 2 in front. This then, I've got 2 oxygens on this side, 1 oxygen on this side. So I put a 2 in front. But then I've got 2 zincs on this side, so I'm going to need 2 zincs on this side. Getting a little bit more complicated now. Okay, so I've got 3 aluminiums on this side. 3 aluminiums on this side. No, it's not 3. 3 chlorines on this side. Only got 2 chlorines on this side, but aluminium's already balanced. Okay, so what you want to do is get them to a number where they're a bit easier to balance. So I'm going to put 2 in front there. So now I've got 2 aluminiums and I've got 6 chlorines. So if I put a 3 in front of there, that balances that out, and a 2 in front of there. This one then, you've got 2 sodiums on this side, so I'm going to put 2 in front there. But now I've got 2 oxygens on this side and 1 oxygen on this side, okay? So that's not going to work. So try and balance out the oxygens then. As you can see, it's trial and error. So put a 2 in front there. Now I've got 2 oxygens on this side, 2 oxygens on this side, but I've also got 4 sodiums. So I'm going to put 4 on there. Okay, so like I said, it's trial and error. See what you can see. This one then, so 2 oxygens, 1 oxygen, put a 2 in front, but now I've got 2 magnesiums, put 2 in front there. Okay, so as an extra super challenge, okay, which I'd like you all to have a go at completing. Okay, so what I want you to do is press pause and have a go. Okay, so I've kind of put together the main things. We've obviously done a couple of other things in this lesson, but I put together the main things, okay? Your answer for this one goes by here, so that's kind of how they do it in the exam for you to then balance. Okay, so pause, have a go, and I'll come back with the answers. So, aluminium reacts with chlorine to form aluminium chloride. What observations would we make? So, we might see a colour change. We might see bubbles. We might see heat or a temperature change. Then it asks me to form a word equation. So it would be aluminium plus chlorine makes aluminium chloride. Then it says what is the ionic formula. So I'll do it by here. Aluminium 3 plus Cl minus. So top 3, 1. Then we're going to swap them. Then we're going to drop them. Okay, so if I was then put it in there, remember I remove that 1, it would look like that. Now I need to balance it out. So on this side I've got aluminium and chlorine. I've got 1 and I've got 2. On this side I've got aluminium and I've got chlorine. So these 2 are balanced, but the chlorines aren't. So just have a mess around with it. So I'm going to put 2 in front there. Normally it's a 2 or a 3. Don't go too high in numbers. That would be 6. That's nice and easy now because I can put 3 in front of there to make that 6 as well. Fortunately, I've got 2 there, so I need to put a 2 in front of there. Okay, so that's kind of the question you're going to get asked. Okay, that's going to be worth about 6 to 7 marks, but they're kind of like a display of all the questions.